Welcome to Module 203B on Temperature Sensing and Control Devices. We're going to take a detailed look at thermostats as a primary interface in your heating and cooling system and the additional components used within the thermostats. This module has three different objectives, and we're going to start with looking at various different types of temperature sensing devices and how they're used. There are a number of different types of temperature sensing devices out there, each with a different type of construction and each with a specific type of job. So we're going to break each one of these down and look to see what they're good for. The most common type of temperature sensing device that we have is called a bimetal device. With any type of bimetal device, we have two pieces of metal that are welded together in order to form one piece. We have three different types of bimetal devices. The first type is called the bimetal strip. With a bimetal strip, when I have two pieces of metal that are welded together, when those two pieces of metal get warmed up, they will expand at different rates. And as they are attached together, when they expand at different rates, they create a curvature or a bend. That bend will either open or close contacts within the device. This concept not only works very well with strips to open and close contacts, but we can also arrange those strips into coils or spirals. As the strip changes temperature, the coil will wind or unwind, and it creates greater movement and therefore has a higher level of sensitivity. This is ideal for mercury bulb switches in the older thermostats. The third type of bimetal device I can have is called the disc type. It has a 2 to 3 centimeter bimetal disc instead of a strip. The disc will hold its shape until the mechanical stress of the heated metal overcomes it, and it changes from a flat to a conical shape with a snap, which means it opens and closes its contacts very quickly. This is ideal for larger incapacitated loads due to the speed of the change. These are typically sealed units and therefore not adjustable, but they're best for monitoring moving air. Another style of temperature sensing devices is a bellows type devices. This takes advantage of the expansion of vapor inside the bellows. The devices are set up a little bit like a teeter-totter, where we have contacts on one side and a metal bellows on the other. The bellows are filled with a liquid or vapor, which is commonly ether. As liquid heats it, it turns into vapor and expands the bellows. As the bellows expand, contacts on the other side will close. This is best suited for line voltage thermostats used for electric heating. Another temperature sensing device that works with the principle of expansion is called the liquid bulb type device. It works with the same expansion-contraction principle as the bellows type. We have a copper bulb holding a liquid, which is better for heat conduction. The liquid inside the bulb has a high coefficient of expansion, which means it has a significant volume change with a small temperature change. It has a capillary tube to go from one end of the bulb up to a diaphragm, and as the liquid expands, the air pressure inside the tube changes and pushes the diaphragm. The diaphragm then closes the contacts. This type is best suited for tank or pipe temperature monitoring because the capillary tube resists ambient air temperature changes. A thermocouple also uses a bimetal junction in order to sense temperature change, but it does it in a different way than we've seen before. It uses the bimetal junction to create a small voltage, typically up to about 30 millivolts. The amount of voltage that is created is dependent on a few different things, including the type of metals used, the temperature difference from one end of the thermocouple to the other. These type of devices are commonly used as flame sensors. They provide power to a relay coil or an electrically operated valve, such as a pilot light valve. If we have no heat, they have no power. Therefore, the valve that it is operating will close, shutting off any gas. A variant of the thermocouple is called the thermopile, and these are also referred to as power piles. What these are multiple thermocouples wired in series. Therefore, they can provide a much higher voltage than a single thermocouple. These are used for electrical loads like solenoid gas valves. Turning to the electronics type of devices, we start with a thermistor, which is a solid-state device. This is a semiconductor material that changes its resistance with the temperature, and it has a negative temperature coefficient, which means the resistance is lower when the temperature is higher. So as my temperature increases, my resistance of my thermistor will decrease. And this is used to sense air temperature, and it is monitored by an electronic circuit. Another electronic device that we can use is called a resistance temperature detector, an RTD. It operates much like a thermistor, but it has a positive temperature coefficient, and they are more accurate than the thermistors. Commonly, we'll use metals with a constant temperature coefficient like platinum, which is a stable metal that resists corrosion and oxidation and has a very high melting point. These are ideal for extreme temperatures such as industrial thermal processing, and once again, these are monitored by an electronic circuit. The last device that we have, and possibly the most rare, is called a pyrometer. It uses a lens to focus the radiation of an object onto a thermocouple. The hotter the object, the higher the radiation of heat, which means the more voltage created by the thermocouple, and that indicates a higher temperature. The temperature of the thermocouple is calibrated to the voltage it creates. It's ideal for measuring high temperatures at a distance and is considered to be an optical device. We would typically use this in places like industrial kilns and metal refineries. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.